Good day on behalf of the World Geospatial Industry Council. My name is Pier Francesco Cardillo, and I'm the head of digital transformation at e-Geos. I also have the honor to chair the marketing committee at WGIC. Yesterday, my colleague, Jim Steiner from Oracle, a member of WGIC policy committee, explained the role of his incredible team in AI Panorama in the welcome remarks. So yesterday was a great success, and today we do the same. So the goal of the marketing team inside the WGIC, which I'm leading, is to support the knowledge sharing and the networking within and outside the geospatial industry, which align with the aim of WGIC. So despite the COVID-19 that is impacting our daily life, WGIC is striving continuously to connect the community. We are working hard to strengthen the relationship between industry represented by WGIC and national and transnational entities that support the geoinformation market growth. My suggestion to all of you is to stay connected with us. So let's connect on WGIC on social media to follow our next event and activities. And I especially invite you to invite particularly the commercial geospatial companies that are growing dramatically in the globe to join WGIC as a member to work together to spread the voice of geoinformation. So let me leave the floor to my colleague Asha to invite our distinguished guests from WGIC member company to explore their point of view and on geoinformation artificial intelligence. So thank you so much, Asha. The floor is yours.
So I'm from a company called Cyient. Hopefully most of you are aware of who Cyient are. Cyient, we're a very large global company with lots of different business units, but I represent the geospatial business unit. And it's interesting that I've been invited to a session on services and geospatial services. Actually, we at Cyient, we see ourselves as a solution company. And the real difference between a services company and a solution company really is quite, it's quite a small difference, but quite a big difference. A solution company doesn't just do what you need and what you ask. We help you find the answer to that problem or help you to find a solution to the particular challenge you might have. So it may be, using a new technology or a new way of doing something to do something you've always done before. And we bring geospatial into those problem sets, and we help you use geospatial technologies, be it geospatial solutions, geospatial data to resolve those problems. And we look at this in three ways, or there's three parts of the journey that most of our customers are on. We help them integrate geospatial data. So that's a company that's maybe using geospatial data already, but needs to find better and more innovative ways of using it. Or it may be using geospatial data in a slightly different way, for example, to help for health and safety or for resilience. We also help you optimize that data. So if you already have geospatial data and flow lines or processes in place, we can help you optimize those processes. And I think I'm going to cover some more of that in a second with AI and how AI can help you optimize. And then I suppose most importantly, we help you transform those processes and transform those business processes that you're using and taking place. So if you're using geospatial data, there might be new and innovative ways that you can use that data, or there might be new ways that you can use the data and the processes and the systems to find new ways of doing business. We've been going for over 26 years, and we've been transforming how customers manage, host, process, share, and visualize geospatial data. We call that the full stack service when it comes to geospatial data, whether it's capturing data, processing it, or ultimately utilizing and exploiting it for your own needs. Just a flavor of some of the projects we do. For example, we work for the UK government, creating the base map that supports all of UK government's decisions. We've been doing that for about 10 years now, updating all of the changes that take place on the UK landscape, whether it's a house or a curb line or a new housing estate. All of that is entered to the map. AI, for example, supports us in the identification of change. So we're looking for evidence of change on the ground, which can be incorporated into the map. We also use machine learning, obviously, which is a derivative of AI. We use machine learning for error identification and theme and trends in terms of issues. We also have a project with UK government looking at farm subsidies. So we use geospatial data to define the payment scheme or the payment values that go out as part of the European CAP system. And actually deep learning and AI is used there to identify the crop type that's growing in a particular field, which is used to verify the claim that the particular farmer's put in. We also, get my slides to work. We have a system for underground pipeline monitoring, so a slightly different service. This is a service where we're using satellite imagery to assess risk against underground gas pipelines. So we use a daily feed of satellite imagery to look for emerging risk. So it could be people building something too near to the pipeline or passing vehicles over the top of the pipeline, really doing anything that might risk the integrity of that pipeline. Most of these pipelines have a buffer within which you're allowed to operate, and we can see whether you're encroaching on that buffer. We also use AI to do feature extraction, to extract all sorts of data from both ground-based and aerial imagery. So that could be any feature from a street light to a stop sign. We're capturing, hundreds of thousands of these features. We have solutions like our virtual walkout solution. Virtual walkout solution enables the planning of fiber networks and utility networks all from the comfort of your own desk, which has become increasingly important during COVID-19 and the 2020 that we're all been facing. This also uses machine learning and artificial intelligence to assist in the planning. So, for example, assisting an operator in what surface type they may be planning near, how many houses they're connecting to, the distance, etc. We have HD navigation services. Anyone that knows Cyient will probably know of our 26-year relationship with TomTom, where we've been maintaining much of their data. And of course, a lot of that data is now supported by AI, machine learning, and all sorts of other technology for finding and identifying change to the network. And that's just a flavor of the contracts we do. But I guess most importantly, why we're here today is, what is geospatial AI, or what is geospatial artificial intelligence? Well, there is no universal definition yet. I think the WGIC and other consortiums are actually working on identifying and defining what geospatial AI is. But what I can tell you is that it is really new. So anyone that's coming into the industry this isn't an old technology. This is really quite emerging and quite exciting. And it is exciting, but it's also sometimes quite disappointing. And I say this, in a geospatial conference, an AI conference, I'm saying this with the kind of humility to say that sometimes it doesn't quite deliver on the expectations. And as a services and solution company, we are there to help you understand where AI works and where it doesn't, and where the best place is for it to work. So, for example, AI really is defined as prediction. It's about predicting something that a human might do, or predicting data. So it's really good for how many houses are there, really good for how many new houses are there, what's changed, what's happened, what's different. It's not so good really for things like the shape of a house or the shape of a property or the shape of an asset. And certainly for the really complex questions like how big is something and how detailed is that thing. And I'm just going to here just a bit of context. If you look at a really simple example from geospatial AI, which is the extraction of houses or the identification of houses, we compare two flow lines, a traditional flow line and an AI flow line. They all follow roughly the same pattern. There's the finding of the feature, so finding a house. There's the identifying of a feature. Is it a house? There's the digitizing, the extraction of the feature, the really important bit. Can we extract the house? Can we attribute it? Well, that's fairly straightforward. If we know it's a house, we can attribute it as a house. And then we do the review and correction. And that's really where we try and clean up the data and make sure it looks correct and it's good for our purposes. The irony when it comes to AI is that we tend to find that the work and the effort is slightly different to the manual processes. So in a manual process, the finding of a feature is quite complicated. Identifying is pretty simple for a human. Extracting takes a lot of time because you're digitizing something manually. But everything else is fairly straightforward. AI, on the other hand, absolutely increases and accelerates the amount of time, the ability to identify and extract these features. It does it really, really well. But the quality and accuracy of that data tends to be slightly or quite a bit below a human-created data set. And that's really because this is all about the prediction section. The prediction of AI features is really in that piece of, this is the house, this is what it looks like, but it's not so good at the creation of the valid geometries and the really detailed data that some of our customers are looking for. And I'd refer to this as the Holy Grail. If we can get from find to review and correction using as much AI and automation as we can, then we've solved one of the biggest geospatial AI challenges. And I'm really here today to try and set that challenge to the industry and the partners within WGIC to work together to try and find really cool and innovative ways of solving this Holy Grail. How do we go from start to finish in the most automated way possible? Using the power of AI, machine learning, and all of the other derivatives of AI to get there, and to see how effectively we can do this, because together we'll be able to create more data, more quality data, and higher precision of data, therefore solving all of the problems that many of our customers have. So I'll leave you with this slide. This is just a slide that covers some of the challenges that the geospatial industry is currently facing. Everything from the demand for maps for machines. Maps don't need to be for humans anymore. They need to be for vehicles and for machines and for sensors and for devices. We have the challenge of AI pressuring prices and pressuring what we're doing. We have new commercial models. Okay, it was a few years ago when Google introduced a free map, but we have seen commercial models change the way that we as a geospatial industry need to provide our data and our services. Location-based services ever present. 5G will connect more things to more places more often, and we'll need better data for that and more understanding of our location. And of course, privacy and security. Where is my data? Who owns my data? And what are you doing with my data? Becomes very, very critical. The more we know about something, the more we know about geospatial data, the more we know about the people creating it and the people partaking in that. And therefore, security becomes a big issue.
Today, I'm going to spend some time looking at how at Terra Analytics we are using AI in some of our business, and that's clearly been exacerbated by the year that 2020 is, because it's forced us to do things really differently in terms of the way we were doing stuff, and especially because a lot of the work in some of our companies and our customers is field-based, and COVID has made that impossible this past year. And looking at how AI and ML is now becoming part and parcel of the everyday workflows that we're doing, and taking those experiences to our customers so that they can embrace AI and ML and transcend their current processes into more modernizing their practices and creating more efficiency in their workflows. And we found that a lot of that is really ended up in, as we heard earlier, in the speed and the improvement in quality of the data that we're producing. So I think today's session I'm going to be speaking mostly is around how we're gathering data using some of the tools, and it's not too different from the earlier speaker, but it really goes into some of the improvements we are making so that we can get better value out of it. So in one of the areas that we do a lot of work in is around property appraisals, which is used for taxation of municipal taxes in the countries. And literally with COVID, site inspections have been either zero or very limited for the bulk of the properties that we're looking at, which has made us look at using a combination of satellite imagery and feature extraction to create 2D building footprints of the cities that we're working in. What we then did is we took that one step further, and after the AI process, we looked at using machine learning to determine the building composition in terms of extent, height, and stories, which has given us a lot more insight into exactly the size of the buildings and what can be derived value in terms of the property valuations. We've augmented that largely by using oblique imagery and street view to ground truth the data. So the ground truth is still virtual, but we're looking at using different views of data to try and collect that, and that's largely giving us additional attributes such as use and quality, which basically is a high value attribute in terms of creating value in the actual properties. And we've found that in most of the cases, the work that we've done thus far has worked very well for residential and uncomplicated commercial buildings, where 90% of the data extraction and collection work has now been done successfully, which is a significant improvement over time in that, we're doing 95% of the work almost in an automated fashion, currently using satellite, oblique, and street view imagery around that. So just to give you some idea, this is the work that we're doing in a city called Nelson Mandela Municipality, which is based in Port Elizabeth in South Africa. And the footprints you see in blue have all been digitized of 30 centimeter digital globe imagery. And from that, we also gathered some of the Z information, which was giving us multiple levels in terms of getting the height of the property of the buildings and the different segments. So this is it's actually a 2.5D simulation of the building, but it gives us a critical thing is the shape of the building, and it gives us the various levels, and indirectly it gives us therefore the volume of a building around that. What we did then is with the volume, using other training data, we've managed to work out some algorithms to look at in terms of volume and height, how we can gather extent of the building. The ground truthing is done almost virtually as well on a desktop, and this is a combination of using the street view and the oblique imagery to try and gather other information, which is done on the desktop level by data collectors as well. So the net effect here is that we are then able to take all of this data and have built some machine learning models to then derive value of properties in proximity to one another. And I'm not going to go into too much detail on the actual valuation algorithms and the valuation models we've used, but literally we've now been able to do a lot of work that was done previously by surveyors or valuers going out in the field, but now they're able to do this all from a desktop, and even not only collect the data, but also look at valuing and analyzing the valuations on the desktop as well from that perspective. So that's one thing. Earlier on, we also looked at in the discussion was around crop detection and farming, and we're using that a lot as well. In this particular slide was largely looking at farm classification of what the farms are currently, for example. And this is just looking at usage. But more importantly, what we're doing there is doing temporal analysis. And the temporal analysis is giving us, the change detection around it, but also looking at whether the farms are being utilized or unutilized, for example. And we're using the NDVI values to try and work out the properties that are just permanent meadows or used for agricultural over seasons and that type of thing. So interesting and important thing is, we have real problems with droughts and that type of thing, and is looking at the effect of droughts over years, and how that has allowed land to be decayed and that type of thing, and around available land for future agricultural potential as well. So that's quite important. And if you know in South Africa, where I come from, there's a lot of issues relating to land reform and moving land into the hands of the masses. And all of this data is being utilized then to try and augment the process of decision making as to who gets allocated land and when and how for sustainable agricultural farming. Another aspect is looking at surface water. Again, because of the scarcity of water in some countries, it's an adequate thing. And if you look at this particular one, it's showing you the decrease in water levels and water availability over a period of time in terms of surface water in some parts of the country. That's a dam on the left is about a few years ago, and then the current level is showing you where that dam now the water levels have dropped in terms of surface water. Which leads me to my final sort of go-to thing is that, we are now getting ready to create GeoBots. And when I say GeoBots when we talk about it internally, it's basically making tools that are able to use APIs that we're developing to replace the mundane human tasks that used to be done. And geography allows us to do that. I think the availability of imagery data is making this even more common in terms of the way we can get it done faster, quicker, and because the imagery data is so up to date, in many areas we're even using this for 1 month or 1 month away from doing a project. We're basically tasking the imagery very recently and very updated to try and get it done as close to the date of implementation as possible. Remember, prior years we would collect out 2 years out and use that same data 2 years later to make assessments. Now we're doing this within 3 months, for example. So we're getting it as close to the time as possible around it in terms of getting up-to-date data. And GeoBots for us is great for collection, updating, and prediction. It's exactly that, and I think this whole discussion is around using AI rather for prediction. It came out earlier as well. I think the challenges we face was often is the more accurate you want it, then the more accurate your training data has to be, which leads to better ground truthing. And I think what we do a lot around the quality assurance is basically making sure that we do ground truth the results prior to implementation, largely because in terms of geography and spatial geography, everywhere is different. There's very little homogeneity in large cities, for example, and we need to then try and look and treat that. So, in the old days, I try and explain to my data scientists, for example, what a break line is. And that's a very difficult concept for them to understand, how to bring in something like a concept of break lines into trying to do delineation so that they don't take data from one area and use it in another area without considering issues around spatial homogeneity, for example. And the other one was trying to get our data scientists to think spatially around it as well. So as geographers and geospatial professionals, we were always thinking spatially, but to bring the scientists into thinking this has also been a challenge. But I think once they get the grip, excuse me, of it, it really helps. And that's because largely we are trying to geo-reference all of the data at the same time to make better results.
How is AI-driven automation transforming the GIS data services business? Can you give your perspectives? Do you see that we are fully there yet to say that, okay, we don't need hundreds and thousands of teams to create our data sets and we can say bye-bye to them and ask them to do some other high-level tasks, or we are not there yet?
Yeah, I think it's the $1 million question, and I think it's the holy grail that I reference in my slides. Whenever automation comes along, whether it's in the car industry or whether it's in regards to AI, first thing people always think is, oh, it's going to take away jobs. It's going to change the way we work. It doesn't happen overnight, and it doesn't happen that quickly. And I think I've just responded to one of the questions on the chat. We keep moving the goalposts to these things. We keep moving the requirements. So yes, we will see a point where the current job of teams of digitizers or teams of data creation people will start to change, but they will for now end up being quality assurance people. They'll start to be people creating labels or doing algorithm creation, all these kind of things. What's been interesting, I think, for us as a geospatial services company is seeing some of the expectations placed upon us by some of our customers and some of the industry, which is, let me paraphrase for a second, but you might have someone who's been to a geospatial AI conference, seen some very nice presentations, and suddenly expects the world to be delivered in 24 hours. Can you make a map automatically? Can you use automation to do this automatically? The answer currently is no, and the answer probably remains no. We can help, and we can use AI to create insight and to create predictions and to create some of the data, but we still need really good people to validate that data and ultimately to check and to make sure that data is useful. Insight is practically useless without an individual looking at it and understanding what that insight is and ultimately validating it. The words false positives are something you'll hear a lot within the AI industry, and until we start reducing those false positives down, and a false positive is just an incorrect data set. It's something that's come out wrong based on an AI result. So until we start to see those come down hugely, there's still going to be the need for people. But what it has done, like I say, is it's changed the expectation. It's massively increased the amount of data we can create. It's hugely increased the amount of data we can, or insight that we've created. So we're seeing a shift in the way that data is looked at and the way that AI is employed. But at the moment, I don't think it's had the big impact on things like jobs and stuff that people would expect. Those are the doom and gloomers that always think that automation comes along and takes away jobs. I don't think that's quite the case.
Yeah, I think the replacement of jobs question will manifest itself in a few years. I can see that happening, because really speaking, I spoke about the bots issue and things like that, where these AI tools that we're developing will automate a lot of the work that was being done. And I think, as Gareth said earlier, it was a lot of the tedious work that is being done and that takes a lot of time, and the repetitive work that we're automating. So it would really, at the low level, and in some of the developing countries, a lot of the work was outsourced to do all the digitization of maps and that type of thing. So I think from that perspective, yes, there will be an impact there. But the issue here is really speaking, if we can get the machine learning algorithms to start doing a lot of the manual work and getting it out of the way, then those individuals who then start doing a bit of the quality assurance, doing a bit more of the value add work to that particular thing, and don't worry so much about vectorization, but then more about value creation on the data itself. And that's where really the optimization starts happening, because we're more interested in what the data attributes are as opposed to the boundary around it. From that perspective. So yeah, I definitely see an impact on terms of the human inference on what is there to derive the data sets, because as we train and get the models to work better, it really does have the speed and the efficiency to try and get some stuff done around it. As I said, we're seeing that 95% of the work that we're doing now can be done at the desktop level that was really done at fieldwork level. It still requires human intervention, but I would say at least 50% of that work that is happening right now is being done by a computer program. So that's really it does bring down a lot of, we're doing that much more in that less time, then it does bring down the requirement for human interaction in certain parts.
How is your organization preparing for this change in terms of realigning teams, especially human resources, so that you are there for tomorrow when we at least see, like you said, 90% of automation coming in?
Yeah, so I mean, much of what I said is what we're doing internally in terms of that. So the realignment of teams, really speaking, it's really about reskilling. So I think what we've done recently is a lot of the data collectors have now become quality assurers, for example, and are looking at that. We're trying to train them to improve the data and also give us more insights into the actual data that's coming out so we can improve the models over time. We're also seeing that a lot of the resources that we're looking at previously, we're making them more analytical as well, and not just becoming data capturers and just gathering data, for example. And I'll just speak about bringing in the data scientists into the team as well. So that's adding a new element to it, where they start doing the modeling. And I think, the other point is that the reliance on using standard software now that does all of this, because most of the times we can go to GitHub or something like that and get algorithms that do a lot of this work for us. So we don't have to buy software, for example, to run the sort of old way of us doing remote sensing and that type of thing. So we're basically having more control over what this particular piece of software or the code that we're using will do for us, custom and purpose-made for the particular application we're trying to drive at. So that's where the domain experts are playing a bigger role.
El Mehdi Salamis asked this question: when we talk about land use land cover classification, supervised or unsupervised classification by NV or ERDA software, is that a type of AI, or what exactly it is? Gareth, you want to take it up? Something like on this question, or?
Well, I think there was a question for Willy, really, because I think it was related to NDVI in his slides. But I think the answer to that question is often it depends who you ask. AI is an all-encompassing term that covers lots of things. And I think one thing I will say is that anyone that's had a lot of history in remote sensing, for example, will begrudge some of the modern technology that looks at things like NDVI, which is a classic remote sensing capability, and then wasn't considered AI back in the day. But I think now, to me, lots of remote sensing techniques, the techniques we were all taught in university, which longer ago now than I'd like to admit, those are a form of AI. It's just they're not AI in the sense of deep learning or some of those more advanced techniques that we're seeing now. So the answer is a fuzzy answer. It's a yes and a no. Willy, I don't know if you're going to disagree with me.
No, I agree with you 100%. You know, when the concept of AI first came about, I had to tell people that it basically is the next version of remote sensing. And the problem is, if you're going to call it remote sensing 2.0 or whatever you want to do, what we're doing right now. But the point is, it is about the deep learning component, because we're not just looking at the pixel, for example. We are adding a lot more value from the historical nature about that area or that location from other data sets that are teaching us more than just what we're seeing in the actual pixel around the values that we're creating. So we're taking what's the NVIDIA value, and we're adding a lot more of that into the model to try and get us a better prediction of what is there.
Question is that in what specific ways can academic research be driven towards industry needs? For instance, in services aspects of AI mentioned by Gareth.
That's a really good question, and I think there's always been a really good collaboration between academia and the commercial sector. I think often, so I'll answer it in two ways. The first thing is the continuation of academia and commercial sector speaking to each other. It's as simple as that. Make sure you're engaging. Make sure you're engaging on the right kind of problems, and that can be through being part of. So, for example, Cyient is a member of the Sprint network in the UK, and a Sprint network is a connection of universities who all have a speciality in a certain area. In this case, it's space-based technology or space-bound technology, and we can use that relationship to provide the universities with help and guidance around a particular problem. And then I think I would flip it. One of the challenges that universities face is they're very, very good at the fine detail of algorithms or analytics or AI, but often struggle with the scale up. So we might resolve a certain problem in a certain area really well, and it may have really good results in that particular area, and it's good enough for a paper, but it doesn't necessarily scale up into a commercial environment or scale up into a commercial offering. So working alongside a commercial entity is a good way of making sure that what you're doing is scalable and can be profitable. Ultimately, for most companies, it needs to be profitable, it needs to be scalable, it needs to be repeatable. So these kind of things, you need to have that in mind, that it's not just about proving that something can be done, it's proving that something can be done effectively and profitably over time and in a commercial environment. And I think that only comes through through really good partnerships. Make sure you focus on the challenge. And I think I'll finally say that I think Willy alluded to this before. It's really important that you constantly focus on the solution that you're resolving. Why are you doing something? Focus on the outcome. It's not on the technology. It's not because we can do something. We actually need to do something because it resolves a problem or it answers a problem. So focus on the outcomes. And there are lots of really good techniques out there that help people focus on outcomes. Like I say, just because something can be done doesn't mean it should be done, or doesn't mean it should be done in a certain way. It's really about whether it derives value for the customer, both financially, but also more importantly, for every other reason.